right, good morning, guys. What I need you guys to do is get into your Bellringer, open her up, and I want you, mine's not written on BT Dubs, so don't freak out. Yours should have writing on it. Today is the 13th, and I need you to write for under the question, touring volcanoes thing, and then you're gonna write done once you've done it, because we're gonna do it together. All right, go back to our class. Go back to not our home, bah humbug, third block. Okay, so we're gonna go to lithosphere. We didn't get to finish this yesterday, which is why we're doing it now as like a bell ringer. You're gonna go to dynamic earth, and then way down here, touring volcanoes part 2. It's 1, 2, 3, 4, 5, 6, 7 from the top. It's right above the Friday folder that I had you guys do last week. So open this up, pop it out. I'm going to make a copy so you can use this time while I'm making a copy to go ahead and actually find what I just said. So again, you should be finding that. I'm making a copy. Boom, boom, boom. Here's your work music. Okay, so hopefully you have it open now. And if you didn't, hopefully you skipped ahead a couple seconds. All right, so what we're going to do is we're going to talk about stratovolcanoes, cinder, and shield volcanoes. And we're going to place them where they are typically found. So go ahead, double click there. Hold on, my goldfish memory. So we're going to look first at stratovolcanoes. Stratovolcanoes are the most explosive, and you're going to find them. You're going to grab the blue one, stratovolcano, and you're going to put them over here. If you look,
classes in the 200 hall are dismissed. Remaining classes at 2:35.
Sorry, guys, doing this at the end of the day. You can see there's a whole big line of volcanoes. Remember, this is part of the Ring of Fire, which goes all the way, comes around here, which is just an area where subduction is happening. So these two plates are coming together. It's a convergent subduction boundary, and you're going to get stratovolcanoes there. Next up is our green triangle, which is our cinder cone. Cinder cone actually pop up on top of other volcanoes. They can pop up on strato or shield volcanoes. So I'm just going to put them off to the side because they can literally go anywhere. And so you see here at the Ring of Fire, there's some volcanoes up in Russia. So I'm going to put it right there. And then the last one is your shield volcano. And those, more often than not, happen at divergent boundaries. So remember, this area in between the Middle East and Africa is currently ripping apart. It's a rift valley. And so we get volcanoes right there. Same with this area right here. These big shield volcanoes occur where the ripping of the earth occurs. New crust is coming up. All right, so we have that down. We're then just going to look at the type of the VEI. So your blue triangle, these guys are going to be the most explosive. So I'm going to put 0 to 8. All right. They can get really, really intense and really crazy. So 0 to 8, that is the most explosive. Then you're going to have cinder cones. Those are like 0 to 4. And then your shield volcanoes are like 0 to 2 or 3. Remember, VEI, if you're not sure where that came from, if you go into your volcanoes part 1, which you should have answered this question. So it's the volcanic explosivity index. There we go. And on here, volcanic explosivity index, 8 is very large eruption. 4 is large, but it doesn't, 1 or 2 isn't that bad. 3 you wouldn't really want to be around. But anyway, around for that eruption. So we're then going to look at the magma type. So we're going to go to this link right here. And what we'll learn and what you'll see here is this is a cinder cone. You can see that cinders, meaning ash, so it's spitting out ash and little chunks of cinder. And you can see it looks kind of like a huge anthill. All right, it's very small though, because remember, this could be found on like the side of this or the side of this. Cinder cones are going to be parts of other volcanoes. All right, this right here is your stereotypical stratovolcano. So this is what you would have on a movie that's about a volcano. Stratovolcanoes are the most explosive, and so most people think of them. And then you have, this is on Hawaii, you have a shield volcano. Now, that I just pretty much gave you the answer. So stratovolcano is going to have an intermediate, typically, type of magma. So you're going to go ahead and highlight intermediate. Cinder cone is going to have felsic magma. Wait, is that cinder cone? Yeah, felsic. Boom. And then the red triangle, which is shield volcano, is going to be mafic. Okay, and we can see, if you look at the type of rocks that were given, let me actually look up a picture of how intermediate magma is formed. All right, images. So what's happening? Ooh, perfect. All right, so as you have subduction happening, this is underwater, and so water gets trapped in here, and it's going to change the melting point for this rock. This rock is going to melt, and oceanic crust is mostly mafic. That's why like your shield volcanoes, like the Hawaiian Islands, in the middle of the ocean. So you're going to have mafic magma because the ocean floor is mafic rock. So that mafic rock is melting. It's going to turn into magma, and it's going to mix in with felsic crust up here. So it's mixing together. That's why it becomes intermediate. Get out of my face. All right. So I'm going to have, mafic oceanic crust sinks through subduction, melts, and rises, mixing with felsic oceanic crust. I'm actually going to grab this picture, and you can search exactly what I searched and pop that in there, but I'm going to copy, paste that in there, wherever I put it. There it is. There we go. Shield volcano is going to be mafic because shield volcanoes form at rift zones where new crust is forming, typically in the ocean, which has mafic crust. Boom. And then this guy, we're not really going to get into that too much. All right, so the type of eruption then. So because you have this mixing of different magmas, it's going to actually make it really chunky. So this is considered very explosive. It's kind of like if you imagine taking a Coke or some kind of soda, versus a milkshake and you try and blow bubbles in them, the milkshake is going to be a lot more difficult to blow bubbles in because it's so thick. And so when it does, when the air does finally get to the top, it splatters everywhere. Same idea with this. The magma and the crust is so thick that when it does erupt, it's much more explosive. All right, felsic or the cinder cone is kind of in the middle. I'm going to write intermediate. All right, so it's kind of in between. So let's highlight that. And then effusive, like the Hawaiian Islands, people live there. It's very calm. You can outrun it. Like it's not going to smack you in the face like a wall of ash or whatever is coming out of a stratovolcano. All right, so how it forms. All right, I actually am going to look at this really good resource that you guys should have used for part 1. But for composite volcano or stratovolcano, it's explosive, violent ash clouds and cinders and pyroclastic flows and lava. It's very viscous. So viscous magma um, causes viscous magma causes steep sides with layers of ash and lava. All right, so actually, if you look at like the side view, stratovolcano diagram, what you'll see is that you get these layers of, nah, that's not right. Yeah, you get lava flows, you get ash, and it's, if we could cut into this, this is the way it would look. And it grows upward because, again, the magma is so thick. As for, we're looking at cinder cones, right? So you're going to get ash, cinders, and volcanic bombs building up around a volcanic vent. All right, so these are typically small, which might help you down here with the shape. Okay, and then this last one, less viscous, so it flows very well. Magma, so viscous meaning chunky, doesn't flow very well. Less viscous means that it flows well. Less viscous magma flows far and wide and makes a huge flat volcano, which is very similar to the reason it's called a shield volcano is because it was huge. If you think back to the Roman shields that covered the whole person's body, they were big and they were flat and they could layer them. So just something to help you remember. Okay, so the next part, we're talking about the shape. Here in my description, I talked about how the stratovolcanoes are very steep because of that thick, viscous lava. So this is going to be the best for that one. It's very tall. The cinder cone, remember, it's tiny, made out of little pieces of ash. So we're going to do that. And then this guy, the shield volcano, is very broad and flat, but it's the biggest one. This could go for miles and miles. Think about, like, people live on Hawaiian volcano, and this is what it looks like. So this is the smallest. This is medium. This is biggest. I know it doesn't really show that. All right. So the most explosive volcano is going to be your stratovolcano, and then your cinder cone, and then shield. Okay. Typically, volcanoes at tectonic boundaries are more violent. I'm going to write a clarifier for that, stratovolcanoes are found at convergent subduction boundaries, so they are the most violent because they have water mixed into the magma, and the magma mixes oceanic and continental crust. So that kind of leads into our next thing. What two factors affect the explosivity of an eruption? So it's composition. So like thicker equals more explosive, and gas, how much gas there is. So this has both. That's why stratovolcanoes are so violent. Even though stratovolcanoes, like in essence, felsic magma is the thickest. But because this intermediate stratovolcanoes have pretty thick, like not as thick as this, but thick magma, and they have gas, it builds the pressure so that it's more explosive. More gas equals more explosive. Boom. All right. Once you're done, hit submit. And I have one more thing to show you. So I'm going to go ahead and submit, or you would go and submit. I'm not going to, but you can get out of this. You've done it. I'm going to erase this because this is the teacher's copy. And I need you to go back to dynamic earth. There's something that's going to be on your test, and it's in one of these CK12s. This one is not due. I was supposed to assign it yesterday, and I forgot. So predicting volcanic eruption. So how do we figure out, hey, if a volcano is going to erupt? And I'm not going to read all of it, but volcanic eruptions can be devastating, particularly to people who live close to volcanoes. Volcanologists study volcanoes to be able to predict when volcanoes can erupt. So one way that they look at, hey, is this volcano going to erupt, is by looking at earthquakes. Earthquakes may take place every day near a volcano, but before an eruption, the number and size of earthquakes increase. Remember, there's magma moving up, so that's going to shake the ground a little bit. This is the result of magma pushing upward into the magma chamber. This motion causes stress on the neighboring rock to build up. Eventually, the ground shakes. Okay, so they're measuring this all the time. Another thing that they'll look at is as magma and gas push upward, it can make the volcano's slope begin to swell. So instead of looking like this, it'll start like bubbling up maybe on one side. So that's another way they can look at a volcano and say, wow, is the shape changing? Because if that's the case, magma's probably moving up. We need to get people out of here. All right. They also measure if there's sulfur dioxide, carbon dioxide, hydrochloric acid, and water trying to escape the site. So they have sensors on volcanoes, not only for earthquakes, but for these gases. And then they monitor it from satellites. So, we're going to move into earthquakes today, and that's kind of why I wanted you to think about, like, oh, we can look at earthquakes to figure out, is a volcano going to erupt? All right, have a good